Now see, we have learned from Newton's second law of motion, force equals mass into acceleration. Now there are various graphs related to this, and these are again frequently asked question, and the same thing will be there in class 10 also. So first of all, we'll be drawing the graph of acceleration and force. So number one graph is acceleration and force. Now see here, I'll do it very slowly. And when you are considering acceleration and force, then mass is constant. So you should write for constant mass, See here, first of all, you should draw the graph like this. I am taking this as y-axis and this as x-axis. So in this axis, first of all, in x-axis, I'll put force. So this is force F. Don't write the unit. And this is acceleration. This is acceleration along y-axis. If you want, you can write in Newton. And it is in meter per second. So remember, see here everyone. Here we know force equals mass into acceleration. If mass is constant, if m equals to constant, then I can write F is directly proportional to acceleration. What is the meaning of this one? When F increases, acceleration will increase. That is for constant mass. Say, this is a very easy example I am giving. I am taking a 10 kg mass. If you apply 5 Newton force, and for the same mass, if you apply a 50 Newton force, in which case the acceleration will be greater? In this case, acceleration will be greater. So when it is directly proportional curve, it will be a straight line passing through the origin. Remember, when no force is applied, no acceleration will be there. Then the graph is force and mass. Number two is, these are easy things, force and mass. See here, force and mass. And remember, in exam, for exam I am telling you, this portion will give you 1 mark. This is 1 mark, and the graph will be another mark, and this is a 2-mark question. So force and mass, you should write it like this. Force is equals mass into acceleration. Now I will take for constant acceleration. So you should write for constant acceleration. Force is directly proportional to mass. That means more the mass, more will be the force required. Less the mass, less will be the force required. So this will be a graph, and here I will take y-axis as force and x-axis as mass. So it will also be a straight line passing through the origin. Normally, if the directly proportional two physical quantities are directly proportional to each other, then remember the graph of that quantity will be a straight line passing through the origin. Now the next graph, what we will do from this relation force equal to mass into acceleration is the relation or the graph between mass and acceleration. Remember, the graph of mass and acceleration for constant force. So number 3 we are doing the graph of mass and acceleration. For, remember, this is very important, for constant force. Now see here, I have applied force. This is again I am taking 10 kg I have applied a force of 5 Newton on this body, and again I have taken the another body having mass 1 kg and I have applied a force of 5 Newton. Now my question is, in which case the acceleration will be greater? Which body will acquire more velocity? Definitely you can see the lighter body, this body will acquire more acceleration than this one. So we can conclude, lighter the weight of the body, more will be the acceleration, and heavier the body, less will be the acceleration for constant force. See, both the cases I have applied the force of 5 Newton. So I can write m into a, I am writing this relation, equals to constant. So I can write it like this: mass is equals to a constant. In exam you have to show this, constant by acceleration. When a constant comes and if we remove that constant, so I can write it like this, that is, mass is inversely proportional to the acceleration. This is another theory question also. So mass is inversely proportional to acceleration. So we will draw the graph how mass and acceleration, we can relate mass and acceleration like this. In this axis, y-axis, I am taking acceleration. So this is acceleration axis and this is mass. And remember, when the mass increase, the acceleration decrease. In this case, the graph will be like this. So don't draw a straight line like this, because there will be a reason in class 11 we will be clearing your doubt why this is not a straight line, this is a parabolic graph. A new term to you. So up to now don't learn too much in class 9. So force equals mass into acceleration. For constant force, mass is inversely proportional to acceleration. So as the mass increases, the acceleration of the body decreases. In this graph you should mention force is equals constant. So remember, these are the three main graphs that comes frequently in the exam. Now this is another frequently asked question, that is how to obtain first law of motion from second law of motion. So this is a 2 or 3 mark question, how to obtain Newton's first law of motion from second law of motion. So we'll start this derivation like this. So I am writing the answer from second law. From second law of motion, we all know force equals mass into acceleration. Now I am repeating the second law, that is, the rate of change of momentum is directly proportional to the force applied. And from there we have derived the relation of force. Force equals to mass into acceleration. Now what is the second law? Second law is, what is the first law? When no external force is applied on a body, then the body at rest will remain at the condition of rest and the body in motion will be in the state of motion. So in this equation, I can write, if force applied F equals to 0, then see these two terms, one is mass, another is acceleration. So mass can never be 0. Mass is a physical quantity which can never be 0. So what will be 0? Then acceleration will be 0. So you should write it like this, as mass cannot be 0. Okay. So acceleration is 0. What is the meaning of this one? If the body is at rest, the acceleration is 0. And if the body is moving with uniform velocity, what will be the acceleration? 0. So see here, if no external force is applied, that is F equals to 0, the body which is at rest will remain at the condition of rest. Why it will remain the condition of the rest? Because the acceleration is 0. And the body which is moving, say I am telling 5 meter per second velocity. If no force is applied, then the body will continue to move with the same velocity, that is 5 meter per second. So as acceleration is 0, so this proves that when no external force is applied, the acceleration of the body is 0. acceleration of the body is 0, the meaning of the statement is the body which is at rest will be remain at rest. So the meaning of this is when no external force is applied on a body. So how I can conclude that? F equals 0. Then the body will not have any acceleration. The acceleration of the body will be 0. And acceleration of the body is 0. What is the meaning of this word acceleration? The body at rest. So you should write it like this: the body at rest will be at rest. So, and the body in motion will continue its state of motion. And after this, in this type of question, you should write it like this: which is Newton's first law? So you should write it like this: which is Newton's first law? Remember, that's why I can prove Newton's first law of motion from second law of motion.